Hi students, quadratic equations. In previous lectures, we learned what is a quadratic equation and the difference between the roots and solutions of a quadratic equation. So the roots, how to find out the roots of a quadratic equation which is in the form of ax square plus bx plus c equals to 0. The roots can be founded as x is equals to minus b plus or minus square root of b square minus 4ac by 2a, and depending on this discriminant b square minus 4ac, depending on the discriminant we identify the nature of the roots. If discriminant is greater than 0, the roots are real and distinct. Roots are real and distinct, and if the discriminant equals to 0, the roots are real and equal. If the discriminant is less than 0, the roots are the roots are imaginary. Okay, the roots are imaginary. Next, we have seen the relation between the coefficient of quadratic equation and the roots of the quadratic equation. So that means between a, b, c, these are the coefficients, and the roots are, let alpha and beta are the, if we assume alpha and beta are the roots, we have seen the relation between the roots and coefficients of the general quadratic equation ax square plus bx plus c equals to 0. And we have seen the transformation of the equation. If alpha and beta are the roots of the quadratic equation f of x, then the change in the alpha and beta, what is minus alpha minus beta, and if the roots are the quadratic equation, how the equation will be transformed, f of x will be transformed. Okay, then we have seen some symmetric values in terms of alpha and beta. So if the alpha plus beta is known, how to find out alpha square plus beta square in terms of alpha plus beta and alpha beta? The sum of the roots and product of the roots are known. Then how to find out some values in terms of alpha and beta? That means alpha square plus beta square, otherwise alpha cube plus beta cube, or alpha power minus 2 plus beta power minus 2. So these values, we have alpha power minus 3 and beta power minus 3 and so on, some different values in terms of the known parameters alpha and beta. That means sum of the roots alpha plus beta and product of the roots alpha beta. And we have seen the condition for a common root. So if one root is common, then we can write it as a1 ab, what is a1 b2 minus a2 b1 into bc, what it is b1 c2 minus b2 c1 equals to ca. So ca minus ca whole square, that means here 1 2 and 2 1. Okay, so we have seen another alternative method to find out the common root. So the two equations are given. If one root is common, then substitute the root alpha in this one and substitute the root alpha in this one, then subtract these two, we can find the value of alpha, the common root. Okay, if the equation is having both the roots as common, then their ratios must be in the same proportion. For example, a1 by a2 equals to b1 by b2 equals to c1 by c2 equals to, that must be in same proportion, it must be a constant. So these are the concepts we covered for the quadratic equations. So these all are the basics of the quadratic equation. Now in this lecture we will try to solve few problems on the basics of the quadratic equation. Let, if one question is given that, so find the roots of the quadratic equation. Let I am considering the question as 6 root 5 x square minus 9x minus 3 root 5 equals to 0. The question is given that, asking us to find the roots of the quadratic equation. So which is in the form of, compare with the, what it is, ax square plus bx plus c equals to 0. Then what is a equals to 6 root 5 and b equals to minus 9 and c equals to minus 3 root 5. Okay, so if ax square plus bx plus c equals to 0, the roots can be founded with the help of the formula x is equals to minus b plus or minus square root of b square minus 4ac by 2a. Okay, now substitute the values, then we'll obtain it is as x is equals to minus b, that means minus of b is equals to minus 9, then we'll obtain it is as simply as plus 9 plus or minus square root of b square minus 9 whole square 81 and minus 4 ac 6 root 5, a is 6 root 5 and c is minus 3 root 5. Okay, c is minus 3 root 5 by 2 into 6 root 5. Okay, if we solve this one, what we'll get? X is equals to 9 plus or minus. So what it is? Minus into minus, this will be plus. Okay, I'm solving. This is the one, square root 1. 81 minus into minus plus, and what it is? 18, 6 into 4, 24, 24 into 3, 72, 72 into root 5 into root 5, 5, 72 into 5 will obtain it is as 360. Okay, so 81 plus 360, square root of 81 plus 360, what will obtain it is as 441. Square root of 441, directly I am writing here, it is as 21 by 12 root 5. Okay, 21 by 12 root 5. So that means now the values of x are, once it must be take plus and another one is minus. So if we take plus, the x1 is what it is? 21 plus 9, 30 by 12 root 5 is 1 root, and x2 is 9 minus 21. That means 9 minus 21 means minus 12 by 12 root 5. Okay, 9 minus 21, 9 is 21 by 12 root 5. Then what will obtain here? We can obtain it is as x1 equals to, can we simplify this? Okay, 12 root 5, 6 5s are 6 2s are, okay, which can be written as 5 can be written as root 5 into root 5. Then root 5 and root 5 cancelled out. Then we can write this is as x1 equals to root 5 by 2, and x2 equals to minus 1 by 12. 12 will cancel out, and minus 1 by root 5. Okay, so this is the way of finding. If any quadratic equation is given in the form of ax square plus bx plus c equals to 0, then we have to use the formula as x is equals to minus b plus or minus square root of b square minus 4ac by 2a. Then compare the given quadratic equation with the general quadratic equation ax square plus bx plus c. Then substitute the values, go on simplification. We will get the two values of the given quadratic equation. Now consider the question. Form a quadratic equation whose roots are, the first one is given it as p minus q by p plus q is one root, and minus of p plus q by p minus q is another root. Okay, he has given that where p not equals to plus or minus q. If p is equals to plus or minus q, the denominator is gets 0 and it does not exist. Okay, that's why he has given the condition. Now consider over here. Let's consider the first root. What it is? The first root, as I am considering, it is equals to alpha, p minus q by p plus q as alpha, and the another root I am considering it is as minus of p plus q by p minus q. Okay, so these are the two roots. If alpha and beta are the roots, so if a quadratic equation is given ax square plus bx plus c, if a quadratic equation is given, we know that how to find out the roots with the help of the formula plus minus b plus or minus square root of b square minus 4ac by 2a. But here the question is given that the roots are given. Okay, he has given the roots and asking us to find the quadratic equation, and we know that any quadratic equation can be written as some x square minus sum of roots. Okay, x square minus sum of roots into x plus product of roots equals to 0. Okay, now we need to express, if we substitute the sum of the roots and product of the roots, then we'll get the required quadratic equation. Now he is asking us to form the quadratic equation. Now we will find the sum of the roots. Now what it is? We are considering the first root as this total root as alpha, and the next root, this total root as beta. Then if we form what it is the sum of the roots, what it is? Alpha plus beta equals to p minus q by p plus q, and beta is minus p plus q by p minus q. Okay, then if we simplify this, what will get? P minus q whole square minus p plus q whole square by p plus q into p minus q. Okay, p plus q into p minus q, and we know that what we simplify it, So a minus b whole square, what it is, here we'll get it as simply I'm writing as p square plus q square minus 2pq, and over here it is p plus q whole square, and I'm expanding minus p square minus q square minus 2pq. That means p square q square will get cancelled out. In the numerator we will get as minus 4pq by a plus b into a minus b, a square minus b square. Then we'll get as minus, what is 4pq by p square minus q square is the sum of the roots. Then what is the product of the roots? If we multiply these two, p minus q by p plus q into minus of p plus q by p minus q, then what we'll get over here? P minus q, p minus q, p plus q, p plus q. Simply we will obtain it is as minus 1. Okay, now we know that the sum of the roots and product of the roots, then substitute in this equation. So a quadratic equation can be expressed as, so now I am substituting what it is, x square minus, okay, now x square minus, what is the sum of the roots? So sum of the roots we will obtain it as minus 4pq by p square minus q square into x plus product of the roots. What is the product of the roots is minus 1 equals to 0. Now if we simplify this, what we'll get over here? P square minus q square, if we take LCM, p square minus q square of x square plus, okay, why? Because minus into minus, plus 4pq of x, and now over here we have minus of what it is, p square minus q square equals to 0. Okay, p square minus q square equals to 0. This is the way of, if the roots are given, if the two roots are given, this is the way of forming the quadratic equation. Now consider another question. What is m by n minus, he has given the two roots as m by n and another root is as minus n by m. Okay, let's consider the one root as alpha and another root is as beta. Then what will get? Alpha plus beta equals to m by n minus n by m. Okay, if we simplify this, what will get over here? So LCM mn, m square minus n square by mn, okay, which is the alpha plus beta. And what is alpha beta? Alpha beta equals to m by n into minus n by m, which is equals to m and n will cancel out, and alpha beta equals to minus 1 again. Then we can write what is the quadratic equation. Required quadratic equation is x square minus sum of the roots into x plus product of the roots equals to 0. Then we can write as x square minus of m square minus n square by mn into x, and what it is, plus of alpha beta is minus 1. If we simplify this, what will get? LCM mn into x square minus of m square minus n square into x minus 1 equals to 0, which is the required quadratic equation. Okay, now we have seen the two type of problems. If a quadratic equation is given, how to find out the roots with the help of the formula, that is the first one. Okay, then what is the next one? If the roots are given, how to find out the quadratic equation, how to form the quadratic equation. Next we're moving forward. So the next problems, what is given, for what values of m the given equation will have equal roots. Okay, he has given the condition. So the given quadratic equation, okay, the given quadratic equation having the equal roots. When the quadratic equation will have the equal roots? If the discriminant equals to 0, then the quadratic equation will have the equal roots. Now compare the first one. What he has given? The first one, x square minus 2 of 1 plus 3m times of x plus 7 times of 3 plus 2m equals to 0, with the regular quadratic equation ax square plus bx plus c equals to 0. Then he has given that the equation having the equal root means we have to use the condition discriminant equals to 0. If we solve this by substituting the values, we can find out the required solution. So what it is? B square minus 4ac. What is b over here? Minus 2 into 1 plus 3m whole square, b square minus 4 a is 1, c what it is? 7 times of 3 plus 2m. 7 times of 3 plus 2m equals to 0. Okay, now if we square this, we'll get 4, and if we take 4 as a common, then I am writing it is as 4 times of 1 plus 3m whole square minus 7 into 3 plus 2m equals to 0. Then we can write this is as in the form as what it is, 4 can be neglected, and if we simplify this, what we'll get? 1 plus 9m square plus 6m minus 21 minus 14m equals to 0. Okay, then what we'll get over here? If we write this as 9m square, okay, 9m square minus 8m, okay, 9m square minus 8m, and what we'll get over here? 1 minus 21, we'll get it as a minus 20 equals to 0. Now again, which is in the form of a quadratic equation of variable m, okay, which is also in the form of a quadratic equation of variable m. Then how to find out the values of m? M is equals to minus b, that means here b is equals to minus 8, a equals to 9, and c equals to minus 20. Okay, so minus b plus or minus square root of b square minus 4 AC, A is 9 into C minus 20 by 2A, 2 into 9. Okay, by 2A, 2 into 9. So if we solve this, 8 plus or minus, and what we are getting? So 64 plus 720, 64 plus 720, we'll get it as a 784 by 18, and over here what you get? 8 plus or minus 28. Okay, 784 means 28 by 18. So then we can take it as, once it is as 8 plus 28 by 18, and another one is 8 minus 28 by 18, then the values of m, what we'll get over here? M equals to 36 by 18 means 2, and another value is minus 20 by 18, okay, which is equals to minus 20 by 18. We can write as minus 10 by 9. Okay, so this is the way of finding the given equation having the equal roots. If the equation is having the equal roots, compare the given quadratic equation with the general quadratic equation ax square plus bx plus c equals to 0. The equation have the real roots only. So what is equal roots? Only when discriminant equals to 0. Then verify the condition b square minus 4ac equals to 0 by substituting the values. Okay, similarly you can verify the second one also. If you verify, you have to get the values of m as, okay, the values of m as what is minus 5. Okay, for the second one, the solution you need to get m is equals to minus 5 plus or minus square root of 41 by 2. Okay, minus 5 plus or minus square root of 41 by 2. These are the two values of m you will obtain. Okay, the next question is, if x square plus bx plus c equals to 0 and x square plus cx plus b equals to 0, have the common roots, where b not equals to c, he has given the condition have the common root. Okay, when we have the procedure that if a1x square plus b1x plus c equals to 0 and a2x square plus b2x plus c2 equals to 0, then what is the condition for common root? ab into bc equals to ca whole square. Okay, which is nothing but now a1 b2 a2 b1 into b1 c2 b2 c1 equals to a1 c2 next c to a1 whole square. Okay, otherwise we have the alternative method that let alpha is a common root for the given two equation. So what is meaning by root? If the values of x which satisfies, okay, the root is nothing but the values of x which satisfies the given quadratic equation, those are called as a root. Now we are saying that alpha is a one root, that means the alpha has to satisfy the given equation. Then we can write the given equation as alpha square plus b alpha plus c equals to 0. Then alpha is common root for the next one also, next quadratic equation. Then we can write alpha square plus c alpha plus b equals to 0. Okay, so while substituting this, then simply subtract 1 and 2. Okay, if we subtract 1 and 2, what will get? Okay, alpha square and alpha square will get cancelled out. We obtain it is as b minus c into alpha plus c minus b equals to 0. So if we take this as b minus c as a common, then what will get? Alpha minus, okay, here it is minus, okay, b minus c, alpha minus 1 equals to 0. So from this one we can write it is as b minus c equals to 0 or alpha minus 1 equals to 0. But given that b not equals to c, so that means if we consider this, b equals to c is obtained, but given that b not equals to c means this is not considered, then obviously it has to be alpha minus 1 equals to 0, that means alpha equals to 1. Now substitute alpha equals to 1 in any one of the equation, either equation 1 or equation 2. Then so what it is, alpha equals to 1 means 1 is a common root for the given equations. So then the 1 has to satisfy the given equations. Then if we substitute alpha equals to 1 in the equations, what will get? 1 square plus b into 1 plus c equals to 0. That means which is equals to our required condition, b plus c plus equals to 1. Okay, he has given that a common root, let alpha is a common root, so the root has to satisfy the given quadratic equations. Then substitute the root in the quadratic equations, then subtract, we will find the root. Okay, now substitute the root in any one of the given quadratic equation, we will get the required condition. Okay, I think now you understand how to solve if the problem is given on a common root. So next question is, what is asking? Prove that the roots of x minus a into x minus b equals to h square are always real. So that means we know that a quadratic equation ax square plus bx plus c equals to 0 if it is having the root size alpha into beta, which is also be expressed as, so what it is, a times of x minus alpha into x minus beta equals to 0. Okay, the what is which can be also expressed as a factor. So now he has given that x minus a into x minus b, so that means which is also be simplified as, so which is equals to a times of x square minus of sum of the roots into x plus product of the roots. What it is, product of the roots is alpha beta. Now given that, so x minus a into x minus b also be written as x square minus of a plus b into x plus ab equals to h square. Now we can write it as x square minus of a plus b into x plus ab minus h square equals to 0. Okay, he is asking that what it is, the roots of this equation. The roots of this equation are always real. When the roots are said to be real, the discriminant is greater than or equals to 0. So that means now find out the discriminant for the given obtained quadratic equation. So now it is b is nothing but, now here the b is nothing but minus of a plus b, and c is nothing but ab minus h square, and a equals to 1 itself. Now find out the discriminant b square minus 4ac. Now that means the discriminant for the given condition is minus of a plus b whole square minus 4ac. C is nothing but ab minus h square. Okay, c is nothing but ab minus h square. So if we write this is as what is, we can obtain this is as a plus b whole square minus 4ab, and we obtain as plus 4h square. Okay, plus 4h square. Then we can write as a plus b, that means a square plus b square plus 2ab, and we'll obtain this as minus 4ab, that means minus 2ab. Then we can write this total condition as a minus b whole square plus 4h square can be written as 2h. Okay, 4h square can be written as 2h whole square. Now check for this condition what it is. So a minus b whole square. Okay, square of any result is greater than 0. Okay, greater than or equals to 0. And this is 2h whole square, which is also be greater than 0. Okay, a minus b whole square is greater than 0, and 2h something square which is also greater than 0. Then we will get the discriminant. This total result is always greater than 0. Okay, the discriminant is always greater than 0. Why? Because the square, sum of the squares always is greater than 0. Okay, whatever the a minus b value, positive or negative, it is square, means it is a positive only, that means greater than 0. Now the discriminant is greater than 0 means the roots of the given quadratic equation, what it is, x minus a into x minus b equals to h square, are always real. Okay, so this is the way of finding. If any quadratic equation is given, ask us show that or prove that the given roots are real or equal or complex roots, then we need to find out the discriminant. Now analyzing the discriminant, we can clearly say that the roots are real. Okay, next question is, if x1 x2 are the roots of the quadratic equation ax square plus bx plus c equals to 0, find the values of what he has given, ax1 plus b power minus 2 plus ax2 plus b power minus 2. Okay, in the question he has given that x1 and x2 are roots of the given quadratic equation. If these two are the roots of the given quadratic equation, so the values of x1 and x2 has to satisfy the given quadratic equation. Then we can write it as a x1 square plus b x1 plus c equals to 0. And next x2 is also satisfies the given quadratic equation, ax2 square plus bx2 plus c equals to 0. Now he is asking us ax1 plus b and ax2 plus b. Now how to retrieve ax1 plus b? So from the first one we can write this is as ax1 square plus bx1 equals to minus c, and if we take x1 as a common from this one, then we can write this is as ax1 plus b equals to minus c. Okay, clearly that what it is, ax1 plus b. Okay, our required is obtained. Then we can write it as ax1 plus b equals to minus c by x1. Okay, right. Now the second one, from this one we need to obtain ax2 plus b, then ax2 square plus bx2 equals to minus c. If we take x2 as a common, then we can write this as ax2 plus b equals to minus c. Then we can write from this one as ax2 plus b equals to minus c by x2. Okay, minus c by x2. Okay, clearly that. And we have given that x1 and x2 are the roots of this quadratic equation. If x1 and x2 are roots of the quadratic equation, then what is x1 plus x2? Sum of the root size minus b by a, and product of the root size x1 x2 equals to simply c by a. Okay, this has to be written when we read the question itself. So x1 and x2 are the roots, means x1 plus x2 equals to minus b by a, and the product of the roots x1 x2 equals to c by a. And what he is asking us to find? He is asking us to find ax1 plus b power minus 2. Okay, ax1 plus b power minus 2, which is equals to what it is, minus c by x1 power minus 2, which is also can be written as, okay, 1 by x can be written as x power minus 1. That means if we take the reciprocal, it will be the minus, then minus into minus will be plus, then we can write as x1 by c whole square. Okay, is it clear? Then a by b power minus 2 can be written as b by a power 2. Okay, then we'll obtain it is as x1 by 2 whole square, then minus whole square means plus only, then we obtain it is as x1 square by c square, the first one. Then from this one we can write it as ax2 plus b power minus 2, which can be written as minus c by x2, what it is, whole power minus 2, and which is also we can written as minus x2 by c whole power 2. Okay, then which is equals to x2 square by c square. Okay, then what is the question he asked us? He is asking us to find the ax1 plus b power minus 2 and ax2 plus b power minus 2 summation. Then if we add these two, okay, ax1 plus b power minus 2 plus ax2 plus b power minus 2, the sum is asking what we obtained, ax1 plus b power minus 2 as x1 square plus x1 square by c square, whereas the ax2 plus b power minus 2 as x2 square by c square. That means we can write this is as x1 square plus x2 square by c square, which is also be written in terms of ABC, asking the result in terms of ABC, not in terms of x1 and x2. Then a square plus b square can be written as, what it can be written as, a plus b whole square minus 2ab, that means 2x1 x2 by c square. Okay, by c square. Then we obtain this is as x1 plus x2, just before we obtain what it is, ax square plus bx plus c, having the two roots x1 and x2, then the sum of the roots is minus b by a. So we can write this is as minus b by a whole square minus 2 into product of the roots is c by a by c square. Okay, c by a by c square. Then what will get the resultant as, so b square minus 2 a square and a square will get 2a 2ac by, okay, a square is put in the denominator, then we'll get it as a square c square, which is our required result, b square minus 2ac by a square c square, which is ax1 plus b power minus 2 plus ax2 plus b power minus 2. I think you understand this. Simply we need to retrieve the condition, what is our requirement, ax1 plus b and ax2 plus b are our requirements. Then after finding this, and we are going for our requirement power minus 2 power minus 2, but the question is asking us to find in terms of, what it is, to find in terms of, okay, to find in terms of the a b c. Okay, then substitute x1 plus x2, sum of the roots for the given quadratic equation as minus b by a, product of the roots as c by a, then we are getting the required result as b square minus 2ac by a square c square is our result. The question is, what is given, if alpha beta are the roots of the quadratic equation ax square plus bx plus c equals to 0, and asking us to form a quadratic equation, then asking us to form a quadratic equation whose roots are alpha square plus beta square and the other root is alpha power minus 2 plus beta power minus 2. Let consider this root as p and this root as q. Then how to form a quadratic equation? If the two roots are p and q, x square minus of sum of the roots into x plus product of the roots equals to 0. That means now we need to find the sum of the roots, whereas p equals to alpha square plus beta square and q equals to alpha power minus 2 plus beta power minus 2. Then how to find out this? Before that, he has given that alpha and beta are the roots of ax square plus bx plus c equals to 0. Then we can write it as sum of the roots alpha plus beta equals to minus b by a, and alpha beta product of the roots equals to c by a. These are known to us. Now the first condition, what he has given, one root is alpha square plus beta square is one root. Let we are consider that root as p. Then what we can write as alpha square plus beta square. So we can write as alpha plus beta whole square minus 2 alpha beta. So which is equals to alpha plus beta whole square means minus b by a whole square minus 2 into c by a. So finally we can write this is as b square minus, if we take LCM, 2ac by a square, okay, which is nothing but alpha square plus beta square, which is our consideration is some root p. Okay, now next, what is the another root he has given? Alpha power minus 2 and beta power minus 2. Alpha power minus 2 and beta power minus 2. We are considering this is as some root q, which can be written as 1 by alpha square plus 1 by beta square, which is equals to alpha square plus beta square by alpha beta whole square. Okay, alpha square plus beta square by alpha beta whole square, but we obtained it is as alpha square plus beta square. Just above we obtained what it is, we obtained b square minus 2ac by a square into alpha beta whole square, that means c square by a square. Okay, a square will cancel out, and alpha power minus 2 plus beta power minus 2, which is our consideration is q, which is equals to b square minus 2ac by c square. Okay, now the alpha square plus beta square value is b square minus 2ac by a square, and alpha power minus 2 beta power minus 2 value is b square minus 2ac by c square. Now find out p plus q, which is nothing but alpha square plus beta square plus alpha power minus 2 plus beta power minus 2. So which is equals to b square minus 2ac by what it is a square plus b square minus 2ac by c square, and we can write this is as, if we take common b square minus 2ac as a common, 1 by a square plus 1 by c square, and which is equals to, we can write this is as b square minus 2ac into a square plus c square by a square c square, which is the our sum of the roots. Okay, then now what is product of the roots? Okay, what is product of the roots? So p into q, where p is nothing but alpha square plus beta square into alpha power minus 2 plus beta power minus 2. So alpha square plus beta square can be written as, so b square minus 2ac by a square into, and alpha power minus 2 beta power minus 2 is b square minus 2ac by c square, then which is equals to b square minus 2ac whole square by a square into c square. Now what is our required equation? The required equation can be written as x square minus of the roots is, one is p and one is q, where p is equals to alpha square plus beta square and q equals to alpha power minus 2 plus beta power minus 2 into x plus p into q equals to 0. Now substitute the values, x square minus, and we obtained alpha square plus beta square plus alpha power 2 plus beta power minus 2. The value is, we obtained it is as b square minus 2ac into what it is, c square plus a square by a square c square into x, okay, into x plus, and the product of the roots, what it is, b square minus 2ac whole square by a square c square equals to 0. And if we take the LCM, our required quadratic equation for the given condition, a square c square into x square minus of b square minus 2ac into a square plus c square into x, okay, a square plus c square into x plus b square minus 2ac whole square equals to 0, which is our required solution for the given question what it has given. So this is the question. Okay, thank you. I think you understand these questions, the concept of the quadratic equations and how to solve the solutions of the quadratic equations based on the basics of the quadratic equations. And thank you. In the next lecture we will come with some more problems in the advanced state, the more than these questions. Thank you.